presenting their talk from the IFoA GI Spring Conference that took place earlier this year on machine learning. So Tom Durkin heads up LCP's insurance consulting practice. He works with a range of insurers on all areas of insurance actuarial work. He's also a non-executive director, has held a number of chief actuary roles, and acts as independent expert for Part 7 insurance transfers. And then we also have Paul. He's an actuary with more than 25 years of actuarial experience across a diverse range of areas and industry segments, which he occasionally shares on his YouTube channel alongside his day job at Aviva, where he's currently Group Actuarial Reserving Lead. So just to tell everyone, so we've got a few external people on the call today, and Paul is going to be recording this talk for his YouTube channel, which will be shared externally, of course. So if you can just keep all conversation appropriate for a public audience. And I will hand over to you both.
Brilliant. Thanks, Charlotte, and hello to everyone. So, thanks for joining us for this talk, which will be about the best use of machine learning in reserving. As Charlotte's just said, we did give this talk to the GI Spring Conference back in May. At that time, we had Charlie Stone with us. Unfortunately, he can't make it today, so Tom has kindly agreed to step up and fill in for Charlie. And apologies for the late rearrangement last time. I lost my voice to the worst cold ever last time around, and I seem to have another cold now, so maybe I'm allergic to this talk in some way. As Charlotte's mentioned, we very much welcome questions from the audience. If you feel very strongly, feel free to come off mute and say what you like, but also, you can put things in the chat, and if you see stuff in the chat you like, then do like it. It will help it to bring it to Charlotte's attention. And just to reiterate that this is a public forum. It will go on YouTube. There's people here who don't just work for the company that a lot of us do work for. So please keep all questions in the public domain. Next slide, please, Charlotte. Thank you. So the main premise of this talk is that we both think that there are significant opportunities to using machine learning to enhance insurers' reserving processes. And this talk is going to cover this in 3 different ways. So firstly, I'm going to share my holistic vision for using machine learning within reserving. This will cover the optimal goals as I see them for getting the most out of machine learning to do the best reserving job possible. Then Tom is going to come into real life and show us some actual practical examples, case studies of how machine learning is actually being used in the market already for GI reserving, with the primary aim of making things quicker and or more accurate. And then lastly, Tom and I, and hopefully all of you, will have a debate about what's next for machine learning within reserving. In essence, how do we go from what's happening now to what could be possible, and what are the pitfalls and issues to overcome on that journey? Next slide, please. Okay, so I'm going to talk you through now my holistic vision for machine learning. Got a few slides to go through, but I think before I start, it's really worth framing the debate, and I'm going to do that by considering where humans, i.e. the actuaries, and robots, i.e. machine learning algorithms, are strong and where they're weak. I'm using a Robocop theme, so humans are represented here by Agent Murphy, a human policeman. Now, when I came up with this theme, I thought most people had seen this film. It's very, very big in 1987. Big film for me growing up, but maybe not quite so well known now. So, I'll try and fill you in a few times when I have these images, and also just to promise this theme will make more sense as the talk goes on.
Paul, it's not often that at a weekend I had to sit down and do some work research by watching a film, but I did do that ahead of the talk back in the spring, so it was great to get that connection too.
And I do recommend everyone checks it out. It is a very good film, lots of life lessons in there, and very relevant to our day jobs, as you'll find out as the talk goes on. So when we think about humans, they are very good at what they do. Obviously, they have a limited time in which to do it. They're prone to errors, particularly when it's a repetitive task. And when they're doing analysis, they have various well-documented cognitive biases that can lead to inaccurate predictions. Human actuaries are expensive, even for professionals, and they accumulate knowledge and experience which leaves the company when they do. But as I said, and in particular, actuaries are good at what they do. We've grown into general insurance and other areas way before there's any regulatory requirement to do so. We're good at bringing experience from diverse projects to bear on the current task. So, for example, if we're looking at given class and we knew it was problematic in our previous company, we're going to be very careful when we look at it in our new situation. We also consider the impact of what we say and do on others. And we automatically have that gut feel, when something is wrong or going to land badly. But obviously, we're very good at talking, much better than computers at talking, so we can engage with senior stakeholders on that human level, which is really crucial for influencing and actually getting things done. Next slide, please, Charlotte. So let's flip it now. What's a robot like? And again, I'm using the Robocop theme here, and I'm representing machine learning as Ed 209. That's the murderous, stop at nothing to achieve my aim, killing machine police robot from the Robocop film. So if you haven't heard me talk about machine learning before, then I might well have just given away some of my position on this issue to you. Now, don't get me wrong, there are many things which machines do well. They do what they're told, quickly, cheaply, and accurately. Even repetitive tasks are no problem for them. However, they will also hunt out any biases in your data with a passion and repeat them in their projections, leading to potential model error. They very much learn in little silos. A machine learning algorithm that has been trained to model, say, motor insurance data really well will be disastrous if then presented with, say, liability data instead, and would also ignore anything else learned in another silo where they modelled property or liability insurance data in a separate algorithm on the same PC, network or company. Robots have no interest whatsoever in delivering messages. They don't want to go to reserve committees, boards or regulators. They don't have that feel or moral compass whether the result is good or bad or likely to cause offence. But they can be used to present results via dashboards which have very high clarity, user friendliness and with great governance, as well as being free of errors. Next slide, please, Sean. So, to me, it's clear that both humans and machine learning algorithms have their uses. And like in the film Robocop, the best solution is a hybrid, i.e. Robocop itself, which protects the world from the killer robots and makes the lives of the humans better. Let's look at what Robocop, or let's call it RoboReserving, can deliver. Next slide, please, Charlotte. So what we're aiming for is doing more in the same time. Insurance is an arms race. So by doing this, it will enable us to dig deeper and perform better analysis, and hence stay ahead of our peers by getting an optimal output for our given inputs. By the humans focusing hard on eliminating biases from our data, the machine learning algorithms can then help us to avoid introducing any cognitive biases into our projections, leading to the best end results. Lots of the intellectual capital in our reserving work will be retained in the machine learning algorithms and tools, so the loss of any one individual team member will be much less problematic than it is at present. The humans can ensure we join up the dots and bring to bear all of our experiences to reserving work, rather than that narrow lens applied by the machine learning algorithms. And, of course, the humans can manage all those interpersonal interactions and presentations, backed up by those great user-friendly dashboards updated in an accurate, well-governed and timely manner. Slide, please, Charlotte. So, before I let Tom give you some real-life examples, let me talk for a few minutes about the kinds of practical applications I think all reserving actuaries should be considering right now. I've broken it down into the natural stages of the reserving process, so let's step through the ways machine learning can enhance each of these stages to help the actuarial team deliver much more than they possibly can at present. I'll start with data in the top right. So we can use machine learning to analyse our policy and claims databases in more detail to get better quantity and quality of potential segmentation for our reserving work. So for example, we might be able to split out injury claims into various additional characteristics that impact claim development, frequency and or severity. So for example, maybe splitting high and low speed claims out into two different segments, maybe looking at type of injury, maybe looking at location. On methodology in the bottom right, we can use tools like k-means clustering to improve our segmentation, taking advantage of all this additional data we've created, but without overloading our work with hundreds of irrelevant or tiny classes. If you're not familiar with And I've even heard people at Lloyd's talking about it now, so it's becoming much more mainstream. K means clustering, groups together segments or policies into K different groups, each with similar characteristics. So we could start with thousands of possible segments for our reserving and end up with K equals 50 or K equals 100 as an optimal mix of insight versus workload. Alternatively, we could use a full-on machine learning model as a companion, and I really emphasize the word companion here, to our normal and enhanced reserving processes, benefiting but not being bulldozed by the technology. And we can also automatically apply multitudes of potential methodologies to each segment to really home in on which are the most optimal ones for each class, which can then be applied with due skill and care by the human modelers. Talking about models, in the bottom left, we can make our roll forward processes much more intelligent and automatic. Again, the machine's highlighting where human intervention is or isn't required, and therefore freeing up the resources for the humans to get fully involved in the more problematic classes, whilst the easy classes are taken care of by the machines. We can use machine learning to get right down into the nuts and bolts of the reserving data, to spot emerging trends and ensure that they are properly considered in the reserving modelling work. Thinking about assumptions, we can use machine learning to select the assumptions for those easy classes, but also to provide guidance on assumption setting for the harder classes, and also to really indicate which classes need that human subjectivity. And again, freeing up those actuaries to have time to actually consider and parameterize those tricky classes in sufficient detail. Thinking about our results, we can allocate these results intelligently down to policy level, enabling Solvency II, IFRS 4, 17, or GAP results to just simply fall out of a single high-level and integrated reserving process, as well as to provide results at the desired segmentation of underwriters or management, where these are frequently more granular than the optimal reserving segmentation. Taking another way, we can use machine learning to highlight significant trends and movements to the actuaries and other stakeholders. We can even come from the top down and use machine learning to predict which classes might be about to run into problems based on the emerging trends, even before the problem itself has occurred. And thus we can then put in preemptive rating or other actions to be taken at low cost and risk to the company. Lastly, on communication at the top left, I've said this a number of times, we can present everything beautifully and accessibly by building self-service dashboards that enable actuaries and other key stakeholders to drill down into their areas of interest or concern, whilst also highlighting the key issues easily to those who want a more holistic view. The automation of these dashboards also makes them available at the point of necessary action, rather than, due to resource constraints as we know, arriving well after the moment for optimal action has passed, as it happens now. Everything on this list is happening right now in some shape or form in the market, and there's huge competitive advantage available to any insurers who can fully implement machine learning tools in synchronicity with their actuarial reserving teams. Let me stop here and pass over to Tom to tell you more.
Thanks, Paul, and good afternoon, everyone. So I'm going to focus on just two case studies of where we've taken the types of principles that Paul's just shared and that holistic vision and put it in place in practice. So the first case study, which we've called Robo Trend Spotting, and that covers three of the broad areas. So it covers communication, data, and results. So first, let me paint a picture of a traditional human reserving process. So one of the first things that we do as reserving actuaries is to review a wide range of development triangles so that we can understand the latest trends, we can understand the business. And that tends to be a relatively manual review process, and it can be really time consuming. So that can take hours to do thoroughly. And typically what that means is, as actuarial teams, we focus just on a selected sample, and there's a real potential that we miss features, as well as taking a lot of time to do that analysis. So enter the Robo Actuary, using machine learning to prioritize the top triangles to review. I can make it really quick, so it can be completed in minutes, and also scalable, so looking across hundreds or thousands of triangles quickly to understand where those trends could be. And that gives you more flexibility then to look perhaps beyond the high level reserving classes and then looking at more granular level to say, well, actually, overall there isn't a clear emerging trend, but within these subgroups, there are some potential early warning signs for future emerging issues. And all this, in addition to giving you more insight, will give you more time to really understand the why. So when thinking about this sort of case study, there are a couple of key considerations. The first is, well, what are the sorts of diagnostics, what are the sorts of trends that we would want to help the robot or the computer to understand and therefore identify on our behalf? And on the next slide, I've got a picture of fanning out, which is just one of the example features or one of the example trends that we would intuitively understand to look for as a reserving actuary. So we can see the cohorts are fanning out to the top left of this slide, and they're highlighted in red there. So how do we go from that intuitive understanding of what a trend is to something that we can help a robot to understand? And actually, feature engineering, which is the technique that we used in this particular case study, is absolutely critical to ensure that that's an efficient process. And actually, you can see over the fanning out, there's a number of different metrics that we've identified. This is only a subset of the total that have been used. Things like the consistency of the cohort before the fanning out starts, the fan distance or the drift ratio, as we also refer to it, which is the distance between those individual cohorts that are clearly part of the fan, and also the number of cohorts in the fan, and actually combinations of those that can be identified using the machine learning tools will help classify whether or not fanning out is present. And we've done very similar thinking for other potential trends as well, including a step change, which is where there's been a group of cohorts that are showing certain development characteristics, and then there's been a change to the latter group of cohorts, or sticking out, where maybe something's occurred just that affects a single cohort. And I should also flag that in terms of the data that this represents, any of the types of development charts that you consider as part of reserving, including the claims, premiums, pay to incurred ratios, anything else that you typically look at as a development pattern, can be something that can go through this sort of algorithm. For those of you that are interested in the types of machine learning techniques that we've used, as a team, we've considered a range of classification algorithms, including convolutional neural networks, XGBoost, and random forest. And in this particular case, we selected random forest because it gave us the best hold cross-validation AUC value out of the methods that I've mentioned. Another really important aspect of the feature engineering is it means that we don't need to put swathes of data into the algorithm. It actually allows us to be a lot more targeted in terms of the data that we provide in, because we supplement the data that we've got with the domain expertise that as human actuaries we understand, and it really helps those machine learning techniques tick. Great. So that's one area that's really important. How do we train the robots to help us as humans? The other component is, how do we package that in a way that is really easy for us to use, and perhaps people with less technical understanding to apply to their day-to-day work? And a really helpful analogy there is if we compare that to, for example, how we use our phones to search for pictures. So I've got 2 young boys, and something that we would often do for a relative in terms of cards, and certainly we did when they were very young, was produce custom cards using online port that allows you to upload those photos and then annotate it. And actually, to do that, I don't need to go through and manually find those photos. All I need to do is type in one of my child's names, and it would come up with a bunch of photos that are relevant to that card. And beneath that, there's a whole load of machine classification algorithms that are being used. And as a user, I don't need to worry about the exact techniques that they use. The important thing is that I have built up the trust in the results that it's given because I've used it, that it's easy to use, and that it's intuitive. And actually, that's such an important part of what we need to do as well in the actuarial space. So on the next slide, I've got a screenshot from our analytics platform, which is LCP and Shoresight, and that's being used to analyze around 100 billion of reserves. And I just want to draw out some of the ways that we've applied that sort of principle and why that's important and why we would recommend that that is something that we embed across all actuarial tools. So at the top left there, we've got a slicing, dicing and drill down. So the first thing that you're presented with is a set of charts that are highlighting the trends already. But then you can drill down further to do that sort of intuitive and real-time analysis that can really save you time as actuaries. On the right-hand side, I've mentioned already the highlighting of trends. So you can turn it off and it will look like traditional development charts, but actually bringing some of those trends to really into focus visually is something that again can really save you time and say, right, what are the most important things here? And then the third one is on the bottom left, we've mentioned around prioritizing the metrics to review. So you can see that there's H's and L's. So actually where there's a high confidence, that's brought to the fore. And when there's a lower confidence, that's also flagged, but actually this might be something that you're interested in. And as part of sorting and shifting through this relatively small number of charts that remain once they've been prioritized, these are really helpful things to have within this sort of system. Very good. So that's what I wanted to cover in terms of the first case study, taking the review of diagnostics from a manual process to one that is a robo-actuary approach, can really save time and give you more time yourself to really understand why those are the trends you're seeing. The second case study is around robo-reserving. And again, thinking back to Paul's holistic framework, the areas that are covered here are around results, assumptions, the models themselves, but also the underlying methodology. And just like the first case study, let's describe a traditional approach. So a human actuarial review, it could start with, again, manual processes, and it can be time consuming to set key assumptions and to consider alternative methodologies. It's also challenging to give a robust rationale for the approach to use. And that gives less time to consider implications and the so what from the analysis. What it also tends to do is that we tend to set for example, the granularity for the reserving early on, and that might not be set based on what are the right homogeneous risk classes that we're seeing, or homogeneous risk groups at the moment. It might be based on a bunch of other factors, things like, well, what grouping did we use previously? What reporting does the business need? How are we running the strategy of the business? And you can see that a number of those factors may or may not also coincide with the best grouping for a reserving perspective. And we tend to spend our time fine-tuning the assumptions within a single grouping or a small number of groupings, rather than thinking what's the wider trends that we're seeing in this data and how can we reserve that for that appropriately. So that's the human approach. Supplement that with the robo-actuary. So here, using machine learning to help set each of the key assumptions. And also, as part of that, provide a range or a suite of diagnostics that then the human actuary can use to review and challenge what the algorithm is suggesting. Something else that's really important for this to work is a measure of quality for the potential reserves. And in this case study, we've used a combination of bias and volatility, and I'll show you a diagram in a couple of slides' time that covers that. Using algorithms to highlight priority areas for human overlay. And actually, when we think about this, we almost think about it into three broad groups. There may be really well-behaved classes of business where the machine learning can do pretty much all the work, a high degree of confidence, and probably the recommendation is, well, unless there's some judgment overlay that the algorithm isn't aware of, probably go with the suggestions from the machine learning algorithm. Through to other areas where the algorithm may say, well, actually, I've got very low confidence here, and there's a real need for human overlay and judgment. I think it gets really interesting when you think about what lies between them, where actually there's confidence in a good number of the assumptions that are being used by the algorithm, but there might be specific areas where it says, well, actually, I'm not so clear what is initial expected loss ratio to pick here, etc. So I'll touch on a little bit on that in a moment as well. Something else that's really relevant to this case study is that we are still using a traditional paradigm. And what that means is the type of terminology that you are used to as reserving actuaries, that the business is used to, are still being used. Things like development patterns, expected loss ratios, etc. But behind the scenes, you're using much more kind of modern techniques to help assess what those individual assumptions are. And that's really good in terms of avoiding a black box. For communication, really helps with that, but also in wider conversations with, for example, the regulator or your auditors. I think these are all really important things for today. I think that will evolve over time as we move away from that traditional paradigm. Okay, great. So that set the scene for the case study. What I'm going to do is just focus on one of the assumptions and how it can be set. So this is the initial expected loss ratio assumption. And one of the approaches that we've used here that's been very effective is to use a package called Profit. So on the left-hand side, we've got a chart, and each of those coloured points here shows the ultimate loss ratio historically coming from the development factor models. And the question is, or the task from this, is how can we help the robot to predict the initial expected loss ratios for the 2020 quarters and beyond. So as I've mentioned, we used a package called Profit, and that is freely available both in Python and R. And it's made up of two key components. So the first is a piecewise linear regression, and that has automated change points. And that is the blue line on the chart. And it's piecewise in that it's made up of a number of different straight lines. And actually the clever bit about that is the Profit algorithm itself automates where those new lines need to start. And Charlotte, if you click on a tiny bit of animation, which brings in the second key component, which is seasonality. So you can see the orange dot at the top there in the middle of the chart. That's referring to Q4. And that's really showing that there is worse performance during Q4. Not at all surprising, given this example is based on a UK motor portfolio. So with those two components and the fact that it's a freely available package, we've got quite a simple model that's easy to explain and relatively easy to understand as well. So a key question is, well, how well does that fit the data? And on the next slide, we've got an example of how it's fitting. And adding those two components together, you can immediately see that there's actually a pretty good fit across those accident quarters. We've also shown on the chart the 80th confidence interval, so we can show that uncertainty coming out as well. Good. So in terms of using Profit or this sort of approach for setting or helping with setting assumptions, there's some key benefits coming through. So we've got a good amount of consistency. It's easier to be more objective, and it's also easily scalable. So for example, we used this on a reserve review for a client that had over 50 reserving classes, and it gave an excellent starting point for our review. And it most importantly allowed us then to focus on the areas where the human overlay was most valuable. So for example, that could be classes where there's the greatest uncertainty interval, or perhaps ones such as fire and theft or certain damage classes where there's been sort of greater increases of inflation. And actually that would be a reason to say, well, hold on, let's make sure that that's within the human actuaries area of review. And there's a number of other benefits there, which I'm not proposing to go through now, but I'll be delighted to discuss any of them later on or at another time. Good. So that's an example of helping with the automated assumption setting. The other part within this robo-reserving work, as I mentioned, is how do we score the quality of reserve estimates? So we've got here a chart that shows for each of those dots is a different estimate that's been produced by the algorithms. And we've also given there an indication of increasing bias, going to the right-hand side of the slide, and increasing volatility, going to the top. And a reminder, because we are in the traditional paradigm for reserving, a dot there, for example, that's been annotated is looking at an incurred DFM all-year weighted average. So it's that sort of terminology that we're used to. Click on one slide, please. Brilliant. And actually, in order for a reserve estimate to be considered high quality, what we're really looking for is something in the bottom left of the chart with lower volatility and lower bias. And actually, you might be in a situation where there is one reserve estimate, one assumption set, which is giving a dot that's actually quite clearly better than the others based on this quality scoring. And then it becomes a lot easier for the algorithm to say, well, actually, this is our suggested estimate for this particular calculation. If there's a cluster of them down the bottom left, then actually you've probably got more of a subjective judgment. And there might be other factors that you apply. For example, I'm a strong believer that if you've used a set of reserving groupings, risk projection groups in a previous exercise, and actually there's not clear benefit in changing them, then I think it's perfectly reasonable, therefore, to ensure there's consistency over time, because that helps in terms of analysis of change. It also helps in terms of communicating those results. Fabulous. Now, Charlotte, if you could click on 2, I've got 2 sets of words that will come up. I'm going to talk about them both at the same time. So how do we measure volatility and bias? Well, we set up here a number of different ways that it can be done. I'm not going to be talking about them in detail, but actually the measures that you use will depend on your views on the book. So a couple of examples there on volatility. One might be looking at roll forward volatility, so the movement in ultimates between different analyses, or perhaps a subsample volatility where you hold back a portion of the data and run the analysis and then repeat that process, and it will give you a sense of, well, how much does our assessment of the reserves change? And the more it changes, obviously, the more volatile that methodology is. And similarly on bias, different options depending on your view of the book, depending on, for example, whether you think there's been a significant change in recent experience, and that might lead you to focus more on more recent diagonals. Or if nothing's changed, then actually you could look at a longer historical period. And similarly, we've got the idea of wisdom of crowds. So the aim that similar to when you guess the number of beans in a jar, do the exact same with the reserving actuary estimates, and looking at the difference across compared to the average across all those estimates. Again, different judgments for how you can measure volatility and bias, and understanding those different ways and what they mean for the results is obviously an important part of ensuring this is working well. Great.
Brilliant. Well, thanks, Tom. Very interesting, and hopefully you're going to get some tough questions on what you've shown once we open it up for debate.
I was promised that only tough questions would come to you, Paul.
So on this slide and the next, we've got a number of quotes which have just come up because you know, before we wrote this talk, Tom, Charlie, and I had lots of discussions and planning, and all of these things, these quotes have been sort of said by one or other of us during those discussions. So we're going to go into a little bit. I'd like to talk to a few of them. But first, maybe Tom, do you want to talk about what you see as the ideal balance between traditional and machine learning techniques?
Yeah, absolutely. So I think there's a real opportunity as an industry, and we can already see that in the case studies we've shared, but also the wide range of industry presentations that we've seen over the last 12 months. I think it's really important that for each new technique that we introduce, or each approach that we change, that we're really clear what the benefits are. So I've seen, you know, potential algorithms that you show it all the reserving data, and the key conclusion is the case estimate is the key driver for what the future claims are going to be. And that's a great example, I think, of machine learning being applied in a relatively narrow focus without necessarily taking a step back and saying, well, what is the domain knowledge? Because any reserving actuary would already be able to say that actually that case estimate is an important thing. So I think it's important that we define the benefit and be clear on the benefit. I think it's important that we focus on the right areas. And actually, I'm imagining at the moment that a lot of it is on individual assumption settings, but certainly over the next sort of 2 to 3 years, I'm expecting a significant shift to more machine learning. And it's really important that we then built up our skill set for challenging it. So things like the bias and volatility chart is a way of assessing the quality of those reserves. And I'm sure there's plenty of other ways of making sure that we're not over relying on the machine learning. And then the final thing I would say, and Paul, I believe we are entirely aligned on this. It can't be done in isolation. There needs to be appropriate review of the results coming through. Otherwise, we start trusting a black box, and anyone who's seen Robocop will know what goes wrong then.
Thanks, Tom. And I think that leads nicely into the will reserving actuaries become obsolete quote there. And for me, that's a massively important question. When I think back to when I started reserving 25 years ago, we spent a lot of time just typing in data, sometimes from faxes, which if you don't know what that is, it's a way of sending data from one phone line to another and printing out in a completely illegible format. We had to spend a lot of time checking, literally dotting numbers on pieces of paper. So of course, with all those restrictions, we were just looking at very high level data, maybe just origin years, development years, just a few classes and a few perils. It just wasn't possible to do more in the time available. Then we started getting electronic data, so we go much more granular, getting claims and policy databases to get more insight. So we didn't just say, okay, we can do the old, simple job in a tenth of the time, job done. No, we said, okay, well now we got this, this saving in time and effort. What can we do more? To understand more deeply, consider more angles. And I really think machine learning is just another step in the same direction. So it's a fantastic tool which is going to save us time. But I really don't think it's sensible to just bank that time saving and say, right, done that. Get rid of all the actuaries, move on. I think we can just do a better job again here to do more accurate work. And insurance is so competitive. It's just a natural step to want to do it better rather than doing it in the old world way. And everyone else is going to be getting better and better than we are. We're going to end up sort of getting less and less competitive advantage. So I just don't think it makes sense to get rid of all your reserving actuaries, and that's even without considering the whole human element. How are you going to communicate these results? There's who's going to know if it looks right or not? Who's going to think, oh my goodness, we need to go and talk to person X before they see these new results? No one's going to be happy if we just get a big red button, we press that, emails out a bunch of results which just upset half the company. So in my view, there's always going to be a need for reserving actuaries, but I do actually think the seniority and skill set of those actuaries will change. We're going to need more of the senior people who can actually interpret results and communicate them well to key stakeholders, which is a really actuarial skill set. And I think we're going to need more and more junior people who are good at doing the coding and handling the data, which is a skill set which actuaries are developing. But we do need to be aware it's not only actuaries who can do that. We are seeing data scientists working for insurers, and I think that's going to be a big threat, for junior actuaries in the coming years. Which then makes me think, so how do we train up junior actuaries? How do we develop those future senior actuaries if we're getting rid of the junior actuaries? And this is where I get concerned, because it is pretty easy just to make a decision now. It's entirely rational now to say we need more data scientists, less actuaries, but that could have really important long-term consequences for insurers in 10, 20 years time when we just don't have those senior actuaries available. Maybe it does make sense. There's too few senior actuarial roles now, and this will just help rebalance that situation in the future. But I'm concerned this is going to lead to a long-term trend where you get senior people who just haven't had that chance to really, like I did, get up close and personal with the data. they haven't spent enough time on methods and assumption setting, and they don't just look at a table of numbers and just get that gut feeling like, whoa, something's wrong here. They can't spot those problems coming. And obviously, if we look at where insurers have failed in the past, then reserving is the #1 cause. So we really need to protect that skill set and those people. So they're there to protect the insurers of the future. In my opinion, being good at reserving requires lots of practical, specific experience, and this is even more important if we're going to start these machines just running loose with the data and the methodology, the assumptions. And so we need people who've got that instinctive knowledge that something's wrong. And I am concerned how the next generation are going to get that. And, reserving is the foundation stone of the whole insurance operation. If you get it wrong, you've got a massive hole in your reserves, your capital's wrong, your pricing's wrong, pretty much game over. So that's why, from my perspective, RoboActuary is optimal. Going any further really does risk long-term harm for short-term gain. Anything else you'd like to say on that, Tom?
Yeah, so Paul, I think I'm probably a little bit more rosy than you on that particular one. And actually, though, I think there was a really interesting debate at a Gyro talk that we did last week on the future actuarial team and how you can develop it. And it was all around how do we make sure that we've got the right skills for the future, given the changing landscape that we're going to work in. And I think what we absolutely must not lose sight of is that the skills that are needed or were needed 20 years ago versus today, they are different, but there are some core threads that are common between them. And actually, I think the one that's really, really relevant here is problem solving. So if we are giving people more automation and more tools, they still really need to be able to do things like sense checks, making sure that the numbers are right, making sure that they can understand what's going on enough so that they can correct those issues when they're identified. But that doesn't necessarily mean that they need to go through the same way that perhaps an actuary from 20 years learned those same skill sets. So in that regard, I think it's right, and I think we can see it across so many industries where the technology has changed and therefore the skill set has changed, but done it in a way that actually is still safe and robust. And I think the other question that really came out there is how quickly do we expect the industry to develop? So, I think very quickly on a lot of these areas. So we're already seeing it. I think 2 to 3 years is a good time horizon for a larger proportion of insurers that are having elements of machine learning core within their reserving process. And actually, even if I compare the market review that we published in 2020, so just last year, to what we're seeing today, actually the views that are seen specifically in this area, there's lots that's still the same, but specifically around machine learning, there's been I think a step change over that 12 months. That market review, if you Google 2020 market review and LCP, then that comes up as freely available online. Some good ideas there if you're looking to think about your reserving process within your firms as well.
Charlotte, I don't know if you want to open up to anyone in the audience who'd like to say anything at this point.
Violently disagree with us or similar.
Yeah, sure. So if anyone has a question for Tom or Paul, feel free to go off mute or pop it in the chat and I can ask it.
Or a statement, doesn't have to be a question.
Or a statement.
You have to be on anything. If not, build up the courage. Please do ask. We'll move on to the next slide and talk about that. But we would very much welcome and be keen to hear your views and your questions. Okay, so yep, a whole bunch of more quotes from our discussions on machine learning. I guess Tom, would you like to kick us off talking about your favourite quotes?
My favourite quote, I like them all, to be honest. I've enjoyed everything that we've discussed in terms of preparing for this earlier in the year and recently for today. I think for me, the middle left really resonates. So good reserving considers lots of different angles. And actually, Paul, I think that plays to what you were saying on the previous slide in terms of how do you become a good reserving actuary. And it's that practical experience, seeing lots of different situations and how they've been interpreted. And I would also say a little bit of not overreacting It's very easy when you're in the moment to think that this is the first time that it's happened, but with some more years of experience and seeing it over periods, that can really help as well. Although I'd also say that the data can help that as well. So actually, if we can move to a place where some of the more anecdotal evidence that is used as part of reserving is actually backed up with, well, this is the analysis that we had from the data from X years ago, I think again that would be a really good step forward in terms of precision with our work. So machine learning is another tool in the kit. I don't think it is the only thing that we should be doing, but I think it's a really important thing. And actually, when we talk about the approach and the strategy for the future of reserving with firms, one of the first things that we ask is, well, what are your objectives? And there's lots of different nuanced objectives. I think that's so important to be clear on that. And even with the same objectives, there's still so many different ways of achieving it. So things like saving time, yes, machine learning can help with that, but also so can a really strong automation of the processes. And what's really important is to identify why you're choosing the approach that you're choosing so that you can make those right decisions.
About favourite quotes, we've got my favourite quote up here, and I was quite pleased to hear a very senior actuary in the market say this only yesterday at a talk I went to, which is reserving is an art, not a science.
And this wasn't you, Paul, was it? It was a different senior actuary, was it?
It was a highly respected senior actuary in the market, so it couldn't have been me. So, you know, and what I mean by that is really that you might get a machine, it can look at the past data and say, optimal solution from that history, but that may still not be the right solution to take for the future. We all know there's so much collateral information that isn't in the reserving data. We've all got stories about, I don't know, inflation kicking on more than expected, and obviously fingers crossed on that one right now, or stated mix changes that we got told about by the underwriter didn't come through, or some legislative change hit the reserves. And there's another great quote which isn't on this page, but I always think about it, which is, if you know what the model is doing, then you're not doing machine learning. And how does using that as, you know, a core of our reserving really fit in with being able to explain what we've done in simple language to key stakeholders? You know, I really do think that human touch is fundamentally necessary. You know, the reserves impact on the performance of so many individuals in the company. There's a direct impact potentially on bonuses, on jobs. You can't just say, computer says no, to an underwriter's desire to expand. So I really do think this robo-actuary, this middle ground approach, will maintain that trust and support within the company so much more than just sort of letting the machine go wild and doing what it wants. If I think, actually laterally, I was just thinking about this. If you think about an industry which we all know is heavily automated, car manufacturing, they didn't sit down and go, how do we get rid of the CEO? How do we get rid of the car designers, the sales staff? You don't walk into a car showroom and the Dalek comes up and threatens to exterminate you if you don't buy the latest gas guzzler. No, they focused on what robots are good at and humans aren't. They got rid of those repetitive tasks, but they kept all that intellectual and interpersonal skills with the humans. Now, clearly, you know, this is not a good example. There was huge human cost in the car manufacturing industry, but, you know, those manufacturers are still viable businesses. I would be very concerned if I worked for an insurer which just dumped all of the actuaries and put in algorithms instead. The penultimate bullet, a full machine learning approach is a complicated Bornhueter-Ferguson. That's essentially a summary of a talk I gave at a few years back, which was really intended to discourage the full machine learning approach. The reason being that most of the IBNR we require in our reserving relates to future claims. IBNER is often low, as you just said, Tom. You know, the case reserves are normally a pretty good estimate of, you know, what those claims are going to be, and there's very little reopened claim reserves. And the way the machine is going to focus on calculating pure IBNR is going to come up with an initial expected loss on each contract and then credibility weight the emerging data against it, which, I mean, that's literally the Bornhueter-Ferguson method, just in an incredibly complex way. And what we know about BF is it just slows down recognition of the actual trends. So a full machine learning approach, ironically, is going to lag the emerging data and make suboptimal reserving decisions with obviously potentially catastrophic impacts on profitability, solvency and decision making. Yeah. Whereas the RoboReserving approach, the middle ground, it speeds up the availability of the crucial information to the actuary and helps to highlight it and emphasise those emerging trends, so we can make sure the reserves are set using the most up-to-date, insightful information possible. And the actuaries have the most time to learn.
You've made a couple of points there, Paul, which are sort of related to how the whole thing in one shot, both on that and the previous quote. And I think one of the reasons why splitting the problem up into a set of assumptions, each of which is understandable, is so powerful. Certainly in 2021, I think that's such a powerful way to make a transition, because you're not saying we are replacing everything. You're saying, well, actually, initial expected loss ratios, we understand that concept. We're currently looking manually through historical data. We're making judgments. What if we can have an objective yardstick based on a set of assumptions that gives us a starting point? And I think that, to me, is there's such a clear case that that's a good step forward. And I think by making that in the different areas we've been reserving, then I think a step at a time we can build out to a fully fledged machine learning solution. And I think that's the way to do it, rather than saying our objective is machine learning. Our objective should be, well, our objective should be whatever our objectives are, be it earlier insights, saving time, be it looking for more granular review of different cohorts. You can sort of, or better feedback cycles to the business. There's lots of different things that have all got very different ways that they could be responded to.
Thank you. We have actually had a question pop up in the chat. So it's just saying, with the demand for data scientists sort of increasing, do you think that the IFoA are doing enough to train up members in that space? Perhaps we need some hybrid data scientist actuaries.
I don't know. I feel like I'm not sure I want to go on the public domain with all of my views on on this. I mean, I think any junior actuary right now should have data science and machine learning right at the top of their wish list for skills. There's so much benefit from it that, you know, they should be doing it. Whether the IFoA needs to create something to do that when there's so much amazing free material out there is a different question. But, you know, if I was a junior actuary, I'd definitely be making sure that Python and R and knowledge of the various machine learning techniques is just sort of bread and butter development.
So, I mean, I would add to that, not commenting on what the profession is doing, but just generally my observation over 20 odd years of working in the actuarial profession is a lot of this learning and development comes from self-drive, of self-propulsion, rather than waiting for a professional body to provide everything you need. Yes, it provides a platform, but if you look at where real progress has been made in terms of new techniques, etc., I think a lot of that has come from an individual's passion. And Paul's alluded to it, but there's just a huge amount out there, and a huge amount of excellent, pragmatic and useful advice in terms of how to start this journey. And actually my advice would be to listen widely, have a bit of YouTube going on in the background when you're going for a run or whatever, in terms of just absorbing that information. The other thing I would like to just say, in terms of a tiny bit of balance, I know there's sort of a sentiment, this is about machine learning, but I think there are some other really important things for the future of the profession as well that complement it. And again, just drawing out 5 themes that came out of a recent survey that we did of over 100 actuaries, and that was in preparation for a recent Gyro talk. So we've got new methods and techniques was up there in the top 5 areas that are the most important skills for the future, which machine learning would clearly be part of. We've got communication, big picture and commerciality, adaptability and flexibility, and critical thinking and interpretation. And what I think is really good there is, first of all, that to me gives a really balanced picture, but also it really resonates with a number of the things that we're talking about in terms of over-reliance. So if you've got critical thinking and interpretation, or if you're adaptable and flexible, then you're in a much better position to use these tools well and develop them over time.
Great, thank you. So we've got a couple more. Is there any last burning questions or comments for Paul and Tom? Be brave. No, it doesn't look like.
If people have questions, we'd be very happy to receive emails or comment on the YouTube video or whatever you want. We're happy to talk about this.
Yeah, exactly. Well, wait until it's on YouTube, and then you can publicly disagree with us. get the debate going.
I've got one quickly, Charlotte, if we've got time still.
Yeah, go for it.
I was just reading the middle right comment. I was wondering whether what the answer or how the discussion went on that point, because obviously COVID's been one of the main focuses of the reserving team over the last year and a half or so.
I can give first go on this, and then Paul, obviously you can add it as well if that works well. So having a clear use of machine learning within a reserving process in response to big events like COVID, certainly wouldn't give you all the answers. There is so much uncertainty there, and actually, if it was well set up, what I would like to imagine is that the machine learning tools would highlight that as part of it. You're saying, well, actually, we're seeing these uncertainties emerge, especially when there's been a few months of emerging experience from COVID. So that's number one. Does it get you to the final answer? No, absolutely not. And that's consistent with still needing a human judgment. Does it make it easier? Well, yes. I mean, if you can more quickly apply the techniques to different reserving groups, or if you can ensure that the standard work is completed so that you've got more time to understand what the trends are and how they're affecting the book, then definitely that makes it easier. And I think that's a really good result from introducing machine learning.
Yeah, just to sort of add on to that, some of the things we said earlier, like the ability to just get key diagnostics in front of people, the ability to scrape out better data, so demonstrating that it's high speed injuries or low speed injuries that have gone up or gone down. I'm losing my room, by the way, so I will have to stop at that point. And yeah, thanks for your time. I need to start, sorry.
No, it's okay. Thank you both very much. It was really interesting and food for thought, and we'll look forward to seeing it up on your YouTube channel, Paul.
Thank you very much. Cheerio.
Absolute pleasure. Good to see you all.
Bye.
Thank you, Tom.
Thank you. Bye.
Bye.